Okay, so thank you everyone for being here. We're excited to have Chris Jordan here with us. Thank you, Chris, for being here as well. So Chris Jordan leads the Data Management and Collections Group at the Texas Advanced Computing Center and has previously acted as Data Reliability Manager for the San Diego Supercomputing Center. He has worked in national research cyber infrastructure for over 2 decades as a staff member and later as the area lead for the NSF Grid and Exceed projects. He currently operates the Coral petabyte scale resource for high value data collections, including DataSafe and many more. So please help me welcome Chris for his webinar today. Thank you.
All right, so yeah, as she so kindly said, I'm Chris Jordan. I'm the Data Management and Collections Lead at the Texas Advanced Computing Center. And I've been involved in DesignSafe for the duration of the project, and I'll talk about that and several other projects along the way. So just kind of quickly, an introduction to what I'm going to talk about today, kind of some of the national scale cyber infrastructure projects that I've worked on and that will inform the talk today along with DesignSafe. Some of the challenges kind of generally and specific to DesignSafe that I think we have faced and will face in the future. A few kind of special use cases that are kind of specific to DesignSafe and kind of general notes on kind of considerations going forward, and especially kind of lessons learned from the perspective of if we were doing a new project like DesignSafe or with similar goals to DesignSafe, what would be the things that I would highlight for people to think about. And I will try and make sure we have some time to do questions at the end. So just a little bit about kind of my background. I used to be at the San Diego Supercomputer Center. I was the data reliability manager there for a short period of time, and also had other roles related to data management. And then before that, my early professional background was doing high performance computing, cluster administration. And then specifically the storage aspects of that. So I have lots of familiarity with kind of the research computing environment, specifically as it relates to high performance large scale storage and the interface to high performance computing, supercomputing generally, and Linux clusters. I've been working with Linux clusters since they were called Beowulf clusters. The main resource that I'm responsible for is a system called Corral. It's on the fourth hardware iteration, so we call it Corral 4, and each hardware generation lasts us between 4 and 6 years. So we started, the first one was a little less than 1 petabyte in capacity, and by the fourth generation, we're up to about 40 petabytes in capacity. And next time around, we expect will be 100 or more than 100 petabytes. So that gives you some idea of the growth. And we do have data. We have data that has been continuously on that system in previous systems for 20 years or more. So we have some experience now with kind of at least the preservation of bits and the various considerations that come in between just preserving bits and preserving meaning and value in data over time. And I've worked on a lot of different cyber infrastructure projects, especially national ones, focused on the data aspects. I was involved in TeraGrid pretty much from the point when it was called TeraGrid and not DTF or CTF, shortly after the PACC and NPACC years, Exceed and Exceed 2, and iPlant. Before it was Cyverse, when it was just called iPlant, I was involved in some of the early kind of data architecture and design discussions for that cyber infrastructure. So I've got a lot of different kind of perspectives in addition to just DesignSafe, and certainly in the course of my presentation today, I'll be trying to kind of give that broader perspective. DesignSafe is an example and has some special considerations, but I really do want to emphasize that, these are kind of common, mostly these are common issues and common considerations that any national or very large scale cyber infrastructure is going to face with regard to data management, interfacing with applications and researchers at different institutions. And just disclaimer, I'm currently not staff or officially appointed in a DesignSafe role. Corral is a key component of DesignSafe, and at times I have been a member of the DesignSafe project, but I'm not currently funded on it, though I do support it in my role as supporting Corral. Okay, so just a brief introduction. I hope most of you know kind of broadly what DesignSafe is, but just in case, it is a national cyber infrastructure funded by the NSF to support natural hazards engineering kind of across the board. So natural hazards being, anything from earthquakes to floods, hurricanes, tornadoes, and engineering being, the built environment. How do we ensure that the built environment is robust under natural hazards or avoids natural hazards, all those kinds of things. And there are lots and lots of applications that can kind of fall into that domain in many different kinds of data sets as well. So there's a really broad range of applications and researchers from different disciplines that are supported by DesignSafe. Kind of in terms of the interface to the user community, the primary thing is going to be the Science Gateway at the web address that I've highlighted there. And the Science Gateway gives you, kind of all of the traditional science portal capabilities. It's got an authentication front end. It's got mechanisms to create and manage data sets, to share them with others or mark them for sharing with others, to request and gain access to compute resources, to share workflows, code, software applications, and eventually to publish data sets in concert with, if you've done research with DesignSafe, had your data in there, you're ready to publish a paper, you want to make the data set available as well. DesignSafe provides a mechanism to do that and then hosts the data set. And there's a separate interface for that. I'll talk about a little bit. So, I think an important kind of component to highlight here about DesignSafe, and again, this is going to be common to most similar projects, is that you have data that spans the entire gamut from, experimental data, data that's just collected from the natural world, to fully simulated data outputs. So basically every kind of data, much of this data could be either output or input, kind of depending on what kind of workflow it is and where you are in the workflow. So a kind of key aspect of this is the flexibility that you have to access and share data across different elements of the life cycle. And just kind of so you can get an example of what it looks like. This is if you've loaded into the DesignSafe portal. This is the Data Depot interface, and you'll see here on the left, there's kind of a few categories here. This is because it's the Data Depot. This is focused on shared data sets. There's another interface for kind of what we call My Data, right, which is exactly what it sounds like. Published NEAS is data from the previous iteration of this project when it was hosted at Purdue, I believe. So you can see we have some longevity in the data sets that we host, even ones that come from the era predating NARI and DesignSafe as a project. And then community data is not necessarily published or data that's associated with publications, but it could be, community data sets of value to the community, even if they're not necessarily directly attached to a publication or going through the publication workflow. And then kind of an example of DesignSafe in context with other kinds of collections with similar national scope. Portico, I don't know how many people are familiar with Portico, but it's a collection, it's an archive of publications, really mostly focused on preservation. And we host a mirror of the entire Portico collection on Corral. That's about 1 petabyte currently, and 150 million files. DesignSafe, currently 2 petabytes, 200 million files. Galaxy, the bioinformatics portal, is a very large, widely used CI focused on bioinformatics workflows and data sets. That actually is up over 5 petabytes of data. And similarly, Cyverse, what used to be iPlant, is close to 6 petabytes now. And kind of one thing I want to highlight, acute to chronic pain is an NIH-sponsored project, kind of a full-blown research study where they enroll patients, collect data, draw research conclusions from the data that they collect. And that's a multi-institutional nationwide study. But you notice the ratio of data size to file count is really drastically different there with others. And I think that's a kind of important point if you're thinking about the storage level, the underlying data that you need to support. It's increasingly common now to see this very, very wide range of average file sizes. And we see that in DesignSafe too. We've had individual files in DesignSafe that are 20 plus terabytes, and then collections that may have millions and millions of files in just a couple of terabytes. The structure of data collections is much more diverse now, I think, that even than it ever used to be. And so, I think it's important to kind of to back up when you're talking about, a national CI and what are the requirements for the data aspect of things, to think about, what is it that people want out of these systems? And certainly from the researcher perspective, from the user perspective, they want everything, right? They want to never have to worry about the total capacity that's available to them. They want it to always be accessible everywhere. But they also want it to conform to their access restrictions that may only, really be clearly defined in their head. And the data should describe itself, right? The metadata should be either automatically extracted, or it should be clearly labeled somehow by the infrastructure. And this is all stuff that really hasn't and probably won't change, right? These are just, people want systems that serve them and serve their needs without having to put a lot of effort into it. And a lot of the work that happens in building these kinds of national cyber infrastructures are figuring out what are the commonalities and what can actually be done given the resources that we have available to us. Right. And so kind of some of the ways that we might group these challenges together, obviously there's the data lifecycle, and I think that's pretty well understood, either intuitively or explicitly. The data generation or collection, the different kinds of audiences that may use the data. They may have different use cases, but fundamentally they want to get the data and put it into their application, or put a subset into their application. If you are successful and things work, then you will get a bigger audience. And those swings in audience and user side can be really dramatic and fast in the globalized internet age. And that presents special challenges in terms of scaling, both just I/O requirements as well as overall capacity. Data policy and kind of regulation, I'll talk a little bit more about this later on, but this is a really key issue that is only going to get more difficult, and it interacts with the questions of authorization, authentication, identity management in lots of sometimes contradictory ways, but it's a really kind of key consideration that I want to emphasize, especially from the perspective of if you're building new systems, think about what regulations they might be subject to, think about what policies you want to apply to them early on, and try and be consistent about that. And then, of course, needs are always evolving quite rapidly. And that's especially true now with lots of new technological changes associated with things like AI, ML, and just proliferation of technology and computational capacity generally. So thinking about this in the national cyber infrastructure context, we need to be supporting, certainly for something like DesignSafe, we need to be supporting all of the different stages of the data lifecycle. If you're Portico, you can draw a bright line and say, well, we're just archive. We don't need to support access. We don't need to support use. But that's the exception, not the rule. Almost everybody else needs to, at minimum, consider archive from the perspective of where does data go when we're done with it, but may need to be like DesignSafe and say we're going to take some responsibility for trying to preserve data over the longer term. And those needs may be conflicting with each other. So again, you'll need to have clear kind of policy and category definitions for how different stages of the data life cycle are handled by your infrastructure and how you communicate that to your users. And of course, not all types of data really fit well into this kind of structure. Not all collections are well formed. You have things like databases and other data that's really mostly useful in combination with some kind of application. Different data sets may work better or worse with different kinds of computational contexts. And you need to at least make some provision for that or be aware of it and know how to talk to your users about it. And then this kind of last point, again, is a really kind of key long-term issue to consider is, who's responsible? Who's responsible for preservation, who's responsible for metadata, who's responsible for publication, all of those kinds of things, aside from researchers who feel their own personal sense of responsibility for the data set and for making it available, it can be really clear, it can be really unclear who is responsible for those different aspects of things. And then this kind of issue of sustainability, and again, this is a point I want to emphasize, is it's not especially, in the kind of national cyber infrastructure context of something like DesignSafe, it's not about what we can do today so much as it's about what we can do today that we can still be doing in 5 years or still be doing in 10 years. And some of those are policy challenges, and some of them are just storage and infrastructure cost challenges, right? So the triangle I have here is cost, performance, and reliability. I'm not sure you always get to choose two, but you're definitely always trading these things off against each other, right? And you need to figure out what your priorities are, and if those priorities are different depending on the category of data that you're working with, which trade-offs you're willing to make. And again, how sustainable are those long term? Can you still be maintaining it in the same way in 5 years, or what's your plan? And that's certainly something I would emphasize, especially from the DesignSafe context or other longer term projects like this, is that the bigger the collection gets, the more successful you are, the more data you have, the more users you have, the more complex all of this becomes, and the more significant sustainability challenges can become as well. And so it's something you want to be thinking about from early on. Right, so at a very high level, what is DesignSafe doing? So we've got like I showed you before, we've got a centralized web portal that's hosted on virtual machines, mostly at TACC. I think we've got backups offsite as well. But the core portal is basically centralized. It's one URL that we want everybody to come in through, one authentication system, one source of truth about who people are and whether they are who they say they are. We have one big data store with multiple kind of areas that are broken down, and we hope that people will assign data to them based on kind of function and sharing and status within the data lifecycle. The infrastructure itself lives on lots and lots of VMs and containers that provide different kinds of functions, and we've got lots of APIs that kind of orchestrate access to particular applications or compute resources, including some of the clusters at TACC, and not just at TACC. We can interface these APIs with resources elsewhere as we need to, as kind of the compute farms. But a kind of key aspect of thinking about compute and data in DesignSafe is that most all of the time, DesignSafe users who are wanting to execute a compute workflow want the same view or a similar view to their data as they have through the portal. And that may or may not be easy depending on how they have chosen to organize their data, how they want to access it, and so on. And then Corral, I don't think I need to spend too much more time on this. Just to emphasize, we do focus it on data sharing and data publication and preservation. We have a separate tape archive called Ranch at TACC, and that's kind of the place for stuff that you want to save for a long period of time, but that you don't necessarily expect to access again soon or share with others soon. Whereas Corral is, if your data is of enough value that you want to share it with other people, with other members of your project, Corral is kind of the resource for that. And we do have a cost recovery model to make the resource sustainable, so that a project like DesignSafe or any others that relies on Corral has some of that cost kind of built into it as the project. And that allows us to hopefully continue to maintain the availability of the resource as long as it has an audience and has data sets that are of value to the community. And it's kind of a key aspects for DesignSafe are that we have lots and lots of different mechanisms to get data in and out of it. HTTPS is actually still by far the most popular mechanism that people use to move data in and out of any system, I think, pretty much. And then we do support Globus, SSHD, those kinds of things. All right, so identity management is really a key thing, and I know this talk is really focused on data, but because so many of the issues that we deal with, especially in something like a national CI context, are about policy and access issues. Identity management is kind of embedded in everything, right? When you come in and you log in on our web portal, you have an identity in the portal, and that's in the DesignSafe case, it's linked to an account in a TACC system somewhere, but it doesn't necessarily directly connect to a Unix or a Windows identity that is meaningful at the level of the system. And particularly if you're working in a project that has many sites involved that are distributed in terms of their administration, then you can kind of never really get that direct a link. You can have mappings, but you're never going to consistently have the same identity everywhere in a way that works reliably and securely enough that you can mediate data access using it. And so you always have to have some kind of policies and some technology solutions that are figuring out how do you interface between the web layer, the global layer, the person who just comes into the system for the first time and signs up for a new account, and being able to execute computational workflows on a supercomputer with access to very large data sets. Because of course, as we know now, plenty of people will abuse those capabilities if they can. And so an essential part of protecting your reputation and protecting the resources is being able to manage that in a way that is both accessible to the user community you want to reach, while also being protective enough that you're not spending your entire time dealing with security issues. And of course, especially in the case of something like identity management, the technology is really, really constantly changing. Okay, so I want to talk about a little bit about data publication and access, and I want to recommend that you ask Maria Esteva from DesignSafe to come and talk about this, because there's a lot of work that I won't speak to today that she and others in DesignSafe have done to kind of figure out what are the needs of the community with respect to data publication generally, and in association with with papers, with research publications, and what's the best way at both an infrastructure and a process level to support those workflows. So in DesignSafe now, we do have we have the I mentioned my data, kind of web-based maintenance of data organization, the ability to essentially build kind of mini collections of data in a typical folder structure inside your project or your my data area, and then to go through a separate publication workflow that kind of makes a publication version of that data. And again, in DesignSafe, we explicitly support all of these different mechanisms for access to data sets that have been published in DesignSafe. And yeah, this is the way that we kind of categorize data in DesignSafe. There's kind of what's called projects, which are intended as shared spaces for collaborators to work together on sharing and building up data sets. What's called my data, which is kind of the personal view. It's analogous to home directories, or if you work on HPC systems, you might have a user-specific scratch kind of area. So it's that kind of space. We have a separate category for experimental facilities, which basically produce constant streams of new data sets. Publications that I just talked about, which is a separate category where we copy data over. So, when you say you're publishing a data set, you're also making a certain commitment about not changing the data set or about the data set being final. So we basically, when you say you're publishing a data set, we take it to a certain extent out of the direct control of the PI, so that they can still update it and version it if they need to, if errors are found or whatever, but that fundamentally it's no longer kind of in their direct stewardship, and they can continue to work on the data set or evolve it over time without impacting the published version. And then there's a whole bunch of kind of project state data is what I'm calling it here. Basically the behind the scenes stuff in databases and files that is used to manage all of these, and where are they on the file system, and what users are parts of the projects, and all of that kind of stuff. Excuse me, let me grab my coffee really quick. Okay. So the experimental facilities is kind of an interesting one for DesignSafe, and it's a little bit unusual in my experience. So there are a number of facilities, typically at universities or associated with them, that have these specialized sensor or experimental setups like shake tables and wind tunnels, but not exclusively that are basically kind of constantly generating streams of data. And because they are because they're experimental facilities, right, their focus is on the instruments that they operate and managing the facility itself, not managing the data. And that's a role that DesignSafe takes on. So typically we have to work with each of the facilities directly to figure out what's the rate of data generation kind of on a daily or weekly basis. How is the best way to bring those data sets into DesignSafe? Can we do it, on a continuous basis as the data is generated or after a data set is completed, those kinds of things. Sometimes we need to make, special provisions to ensure that we can bring data on at an appropriate rate. And you kind of monitor and continue to communicate with those facilities over time to understand what their ongoing requirements are. And of course, a big part of that is, the instruments are all getting better. Data generation is all, significantly increasing just in terms of kind of the raw bit rate of anything, video recordings, digital imaging, any of that kind of stuff. So we need to try and coordinate with them to a certain extent to ensure that we have appropriate abilities to bring on those data sets as they're being generated. And another kind of not unique to DesignSafe, but aspect that I think is of note is Python notebooks, the Jupyter Hub facilities that have been built into DesignSafe for quite some time now, and I think are pretty popular as basically as a way to quickly implement and then share workflows or different kinds of data analysis. There's a lot of stuff that can be done fairly quickly and easily with Python. It's also a really good tool for education and training and various kinds of data analysis. And so we do support a lot of these, and we do very regularly have trainings that will involve, dozens of new users coming in and using Jupyter Hub, which basically provides small containerized environments for Jupyter notebooks running Python code and have access to DesignSafe data sets to do computation. And that has, because that has grown and grown over time, that has been a kind of challenge in terms of providing access to the data, but without kind of getting into that space where you're really looking like an HPC cluster in terms of the IO and the management overhead, when we also have HPC clusters, and so there's kind of challenges about managing the overall load, ensuring that people have access to the data that they need, and ensuring also that there is a accessible transition to the HPC environments when people kind of scale up to the point where their needs really mean that they should be in an HPC environment, even if they're still running Python. And then we have this other category of kind of what I'm calling here special data sets. But basically, this is all of the kind of stuff that isn't going to fit into the more straightforward file system context that we support with DesignSafe. So, usually this is stuff that needs a database or may even need a more specialized application. It could be something that's reliant on GIS, for example, in order to make sense or be meaningful to the user community that's the target of the data set. And so typically, there's not a good systematic way to support this kind of a need. So this is an area where we do a lot of kind of in-person consultation with folks who will, they'll find out that the resource is available, and they'll come to us and they say, we have this data set, we want to share it with a wider community, but we have these kind of specialized requirements. And so we do sometimes need to work with these groups to set up specialized databases, or we may just set up an access to a virtual machine or a container for them to set up their own application code, find an appropriate place within the DesignSafe data store to host the data and connect it to the application. And in a lot of cases, then provide some special utilities that are available through the portal to facilitate accessing the data. So, little bits of Python code or something else that provides a front end to the data sets for people who want to query it or pull out subsets for analysis. And then kind of just a broad sense of how much this has all grown. When we did the transition to DesignSafe on Corral at TACC, it was a little bit less than 100 terabytes, I think, in all. That was, I believe, almost 10 years ago, and so we're now at 2 petabytes, and we now expect to be adding at least 500 terabytes per year. And then, in a few years, possibly in as few as 5 years, we'll be adding a petabyte per year. And, of course, we're also trying to save everything that we have from the past. And this isn't always predictable, right? Especially with something like natural hazards. You have natural hazard events that happen, and those may generate large new data sets or large new requirements in a very non-contiguous kind of pattern. And so it's you always have to ensure that you have some capability to support the unexpected. And we do see, bursts of growth and then relative periods of lesser growth. But you have to do all of this in a way that is also sustainable, right? It doesn't do us any good to grow to 5 petabytes in a year if we then don't have any money to maintain the system next year. And of course, it also all comes with more users. So we're up to I think thousands of users, and at any given point, any one of those thousands of users could ask for any of the 200 million files that we have available to us. So all of those challenges continue to grow over time. And this data oversight, I think, is an increasing area of focus for DesignSafe, but again, kind of generally, I see this across the industry, across different CI projects, right? And this is basically understanding what it is that you have, who owns it, who it's available to, what kind of file it is. And how long has it been there? When was it last accessed? All of that kind of stuff. And the reason you want that is you want to know if one particular user or project is disproportionately using the resources. You want to know if you have data that's never being touched or that's being touched all the time. Stuff that's just generally anomalous in terms of the collection structure or other aspects. I mentioned a 20 terabyte file. There are legitimate reasons for 20 terabyte files, but there are also cases where just a mistake in coding produces a 20 terabyte file, and you want to be able to catch those kinds of situations. And especially as data protection and access concerns become more significant over time, you want to ensure that someone's data set is not available to a wider community than they want it to be. And so in the DesignSafe context, they have already built some systems to do that, and we're planning to test some new ones, as well as expand the non-commercial options that we have to do what I think are broadly called data catalogs. Systems that basically scan a whole file system or a data store and catalog all of the data and all of the metadata about that in a queryable database. And depending on how sophisticated you get with those, they can also do things like identify file formats, look for stuff that looks like PII inside text files, enforce specific sets of rules on data access, all of those kinds of things. And that is right now, those are kind of relatively novel technologies, but I'm seeing more commercial vendors offering them. And my very strong suspicion is that within 5 to 10 years, this kind of data catalog capability is going to be just considered to be the price of doing business if you're offering any kind of enterprise or near enterprise storage solution. And data protection in this particular context, what I mean by data protection is protecting data from unauthorized access or alteration. And this is something that's not often considered really seriously in big open science projects, because we are oriented towards sharing data and publishing data, and we want all of the data to be open. But even in those contexts, you still want to have some level of data protection. There was a famous case I remember from several years ago now, where an astronomy group was collecting, doing telescopic observations and storing all of their telescopic observations on a website, which was open to everyone. And so some other research group was just reading all of their observation data as they were generating it, and actually beat them to publication because they had access to the data that technically they probably shouldn't have. And certainly the original research group that had put the energy into the observation was very mad about it. But of course, you could also have cases where it turns out there's a problem with the experimental protocol. And if someone is trying to draw conclusions from your experimental data before you've actually processed and published it, they'll get the wrong conclusions. So even if you leave out the question of credit, there's very good reasons why you want to be able to protect your data from unexpected access. The challenge comes when you have to actually define what that means. It's really common nowadays for my interactions with, especially users who come in through a web gateway, to kind of assume that the system does what they want it to do, and that it will have the same defaults at the system level that they kind of have mentally in terms of their model of what they're sharing and with who. But that's basically never true. It's rarely the case that the default is what you really want. And so there's a lot of kind of education and policy work that needs to be done kind of on a regular basis to ensure that users know they have to think about this, and that they know what the knobs are that they can turn to protect their data and then to open it, and what it means to open their data, who you're opening it to, all of those kinds of things. And just to mention here, the whole category of regulated data types, things like HIPAA, ITAR, and FERPA. We do support this at TACC. DesignSafe is not currently, but there's certainly, you can imagine contexts where this would apply to data in DesignSafe. And it's certainly something that you need to be able to consider and potentially support if you're running a CI at this scale, because these are policy and practice issues, right? It's about encryption. It's about being able to ensure that data has the appropriate protections across the board, that you can educate your users about those. And all of those are continuous from open access to even classified data. It's all the same kinds of things. And so it's good to think about this as part of your spectrum of policy responses. And just to say, we have worked with, and we do have mechanisms to interact with things like commercial cloud. And I think they're really useful, particularly for new hardware, or if you want to test something out on a new GPU. that NVIDIA wants $500,000 for or something like that. A commercial cloud can be a really good mechanism to do that, but it doesn't work well for anything data intensive, mostly because of the cost and data movement. But also S3 is really challenging for big shared data management if you're not putting an application in front of it to do all that for you. File systems are a little bit, something like POSIX is a little bit better adapted to, big projects with complex data management needs. And I think we're getting to the end of the hour, so I'll skip this one. And here's here's some other topics that we could talk about slide. Internet of Things, it's a buzzword, but it's real in the sense that everything has a chip in it now. Everything has either cellular or Wi-Fi access. Everything is a potential data source. And there are genuinely amazing things that you can do with that and really interesting applications downstream of that. But also it's a huge new data challenge. It's a huge new security challenge. Lots of kind of interesting consequences of that. And then of course, AI and ML techniques are still pretty hyped and justifiably so. Particularly in the context of scientific applications where you can use these algorithms to uh, vastly improve the efficiency of your overall computational workflow. That's kind of what I would emphasize in this particular context, just in terms of conceptually, it increases the people's understanding of the value of data as just a resource, but it also is kind of generally increasing the volume of the data and the I/O needs because everybody wants huge data sets and wants to feed them into GPUs. And that's mostly so far been true regardless of the discipline. And publication and preservation of data sets for research is a very broad and complex topic. I'll repeat here. You should ask Maria Esteva to come and talk to you about that. And then just security context generally much more challenging. The number and sophistication of the attacks is just wildly higher than it ever was before. And you need to be much more aggressive in any kind of security posture, compared to 10 years ago even. All right, I think I can stop there. Yeah, whole bunch of other names of people who are responsible for leading DesignSafe and implementing various aspects of DesignSafe. And then I'll go back here.
Thank you very much, Chris. Does anybody have any questions or comments?